It is hard. It's a little tricky. So I believe in you. All right, let's discuss, in fact, inspired a little bit from our warm-up today, this idea of like combining functions in various ways. Okay. So today, I know these are things even in the summer packet that you did, the idea of multiplying two functions together. In fact, you doing the warm-up today was me assuming that you know what it means to multiply or divide two functions, or add or subtract two functions, or compose two functions. All those things I think are things you've studied before. The one extra piece that we'll add along the way today too is this idea of the domain of those things, and we'll just try to talk about these things with a little more care. So I think you'll see that happen right away, okay? So on this slide I have the following, I don't know, you might even call them obvious propositions. That by f plus g of x, what we really mean is just take the symbolic representation for f and the symbolic representation of g and add them together, right? Again, I mean, all of those are maybe no surprise. They happen in the way exactly that you would expect. The thing I want to really kind of come in and talk about a little bit is this piece down here about those. That the new domain is the intersection of the two domains we just talked about. In fact, you saw that happen over here as we constructed an answer to 6E on the challenge problems, right? See that we have the domain here is x greater than or equal to 2. We have the domain here from the division of x minus x can't be 17. And when we combine the two functions, we have a domain that is the intersection of the two, right? That's the kind of thing that's happening here, yes? So in fact, with this sample problem you're about to do down here, the interesting part of this problem is not writing down what f minus g is. In fact, I'll do it for you now. The interesting part is the fact here. State the domain. Sorry, I'll write f minus g. My bad. ln x minus square root of 2 minus x. All right, so the interesting part is not that. It's you then, in a minute here, I'll give everyone a chance to think about it, is you thinking about what the domain of that should be. I'd like to have someone tell me that in a minute here. You want to say hi, Mom?
Hi, Mom.
What?
We're recording.
Oh, you recorded that whole time?
All right, Jesse's on. Just know that this is going out to the whole world. You know?
Oh, God.
You're on. If you get this wrong, nobody watches.
My face.
Yeah, but I just said nobody watches them except for you guys. So. Very low quality lessons. All right, so we're taking the domain of this guy, and she's intersecting them, and she gets, I don't know, what are you going to get? What do you think? X is greater than or equal to 2. X is greater than or equal to here. Wait, what's the domain of this guy? Let's do the g of x first. What would that be? What's this one? This is a little tricky because it's not the square root of x minus 2. It's the square root of 2 minus x. It's not merely cosmetically different. It's substantially different. Huh? X is, let me make sure we're saying that right. X is less than or equal to 2. Try some numbers, make sure it works. Yeah, if we plug in 1, we're okay. If we plug in 3, we're not okay. So I think you said it right. Does that feel right now? Okay. What about this guy? Just L and X. What's the domain of just L and X? It's definitely not equal to 0. We can be more precise, maybe. X is greater than 0. Is this coming back to everyone? Cool. So what is the combined domain? Do you want to say it, Jesse?
0 to 2.
Yeah. All right, so that's the thing we want to concentrate on today is this idea. Even if without this discussion, if I just showed you this expression, you would be like, yeah, this prevents me from plugging in negative numbers and 0. This prevents me from plugging things bigger than 2 in. So this is the domain. You know, you might just kind of think about it that way too.
The domain is
So the domain is the half open interval, 0 to 2. Yeah, you can't plug in 0. You can plug in 2, and you can plug in all values in between. All right, moving smartly along. Again, the trick here is not as much writing down what P divided by Q is or what Q times Q is. It's more about the second piece like we just did. So do take a second to do those. And focus your attention very carefully on the stating the domain piece. No. I mean, All right, so the question is, of course, like I said, the question of interest is what's the domain? So let's hear from some people on this. How about Sam? What's the domain? The first one. You get that one yet? Or?
I said P is greater than 0.
Good. I think you avoided the pitfall of just saying like the one temptation here would be to like say, okay, well this is 0 to infinity. This is all reals. Those are the two domains. The intersection is 0, including 0 to infinity, isn't it? So, well, she's right though. Why isn't it just the intersection of the two? I don't know. What'd you say, Sam? Like, why did you not include 0?
Because you do not have a fraction over 0.
Right, yeah. I mean, this is here too. Just no one talked about it on the last slide. Okay. Moving. Just want to make a point here. All right, good job, Sam. All right, and then, how about Keisha? What about, can you take the second one, Keisha? What do you think? Greater than or equal to 0. And explain yourself, because I hear some people who might say, wait, when you simplify this, because I think you're right, I feel good about what you said. But when you simplify this, you just get t, someone might say, right? And I think that person would be right, but talk to that person for a second. The person who might say, isn't the domain all reals? I got t.
Because if you plug in like say negative 2, then it's imaginary, so then you get rid of it.
Yeah, so you can't, this is, the fact that you simplified, that was your business, right? You did that. You did that. The function we're talking about, all of us, is this function, right? I think we are right, just to be clear, I think we are right to simplify it. I think we should simplify it to t. That's a good instinct. But when it comes to actually saying what the domain is, make sure you go back to actually what we're talking about, and that's q times q, right? Looking at this expression, I think it should be clear that t needs to be non-negative. Do you agree? And furthermore, if you want to see this happen on your calculator, feel free to just type in on y1, root x times root x. You'll see a graph of y equals x, restricted to only the non-negative numbers, right? So you'll see it. It'll whoop, like that, a little ray out into the distance. Yeah.
Wait, so y again would be just equal to negative root 2 times negative root 2?
Wait, so this comes out to be t. Do you agree?
Yeah, I know, but why did you write negative root 2?
Oh, because it's q times q. So just this function times itself. Negative root 2 times negative root 2.
Wait, let's go.
Ananya?
So like I know how you say q times q and then that's the negative square root t times negative square root t. But where does the other t go? It's like q
So-
times q times t.
So we do agree that this is like root t times root t. The negatives go away, right?
Yeah, and that's equation for regular t.
Right.
But the equation says q times t.
Oh, I'm sorry. That's our notation. It's confusing when we write that, just like I wrote up here. What we mean is not like a times b times negative x. What we mean is a of b, a times b, that function,
X.
evaluated at negative x. Yeah.
Oh, okay.
Yeah.
So then the answer it would be like t of t.
Yeah, you can maybe just find the person who did this first back in mathematical history, and you could probably just punch him in the face if you don't like that. Because you're right, it's weird, right? It is a little strange to see that, you're right. Okay. Let's talk about composition of functions, and let's also, again, be very careful, because I know you know all about compositions of functions, at least I think you have some experience with it. Again, let's pay attention very carefully to the domain piece. I think that's the tricky conversation to have. And I've intentionally given you a challenging example to work through here. Okay. So remember, also just for the sake of a common language here, remember that we can write the composition of f of g in either of those two ways. That's not the same symbol as a closed dot, it's an open circle. You can say fog if you want. I'll forgive that. But yeah, what that means is evaluate g first. And then the result of that, plug into f. I'll call on volunteers in a minute to give me the algebraic expressions for a and b, and then call on 2 people to do that. And then we'll take volunteers to come up with the domains. Because again, that's I think a little trickier. Yeah. Reggie? This is your friend Antonio over here. He's offering you. We're all right here, listening right now, we're all feeling really bad for you. Okay? So you're blind to the back, so come on over.
Thank you, Antonio.
Meet these ladies.
Ready to calculate?
Okay, this does cost extra, that can be a problem.
How much is my
It's like the big old circle.
I want to be in the whole circle.
Sorry, maybe next to me, Charlie. Shoot, where is that? Oh, Brandon.
What? Wait a minute, what is that?
Get ready. 30 seconds.
It's not what I'm thinking. Why are you?
All right, let's come together. Kim, give us A, please. Kim, f of g of x is. F of g of x is. Wait, it's Kim, guys. It's Kim time. Sure.
I got 4x to the third.
4x to the third. She did that by doing x to the 3 halves. What is that? To the third, to the second, right? Like that. Is that how you did it? Right? Okay. Whew, good. We'll come back again in a minute. We'll come back and talk about what the domain is there. Brandon, you think you can take B?
4x squared plus 2 with 3 over 2.
Good. And then do you have a way of simplifying that? What do you think? Just gonna push your limits in terms of your rules of excellence from algebra 2. See how you do.
Square root of
Say what again?
cube root of 16 and then plus x.
Well, careful. Make sure you understand which power and which is the root. When you raise something into 3 halves,
Oh yeah.
what are you doing? Which is the power, which is the root?
Oh, it's 8x
8x. 8x to the third, you guys agree? You're feeling way up. All right. Now comes the tricky conversation. As if that wasn't the tricky conversation. It's still like a little bit of a stretch to remember our rational excellence from algebra 2, Mr. Chase. I understand that. But let's also now say what the domain is. Volunteer to just step out and take on A. What do you think?
I would say all real numbers.
Okay, well, that does seem to be the domain of 4x cubed. You're right. But go back to the original expression. Again, the simplification was our business. I think it's right to do, but you want to revise your answer looking back at the original expression?
0 included in 3.
Yeah, x needs to be 0 and up, right? You see why? Because the original function, we've got a square root function here, don't we? Try plugging a negative number into g. F of g of x takes values into g first. So anything that g rejects, f of g better reject too, right? Right, that's for
So
sure.
connected.
All right, so we need to say that. What about B? Anyone want to step out? No, please. That we are going to love you no matter what. Yeah, you want to take a risk? Go ahead.
All real numbers.
All reals. It does seem. Well, do you want to tell us why you feel so confident about that?
Because you square it, so whatever result you have will be positive when it goes into when you make it to
Yeah.
3 halves.
Yeah, I mean, really, as what is G down here, the outside function? What is G concerned with? Is it concerned with the domain of f inside here? No, it's concerned with the range of f, isn't it? Because the range of f is what G will be accepting, right? Stuff that comes out of f of x that G is going to be wondering about. And like you said, f of x kind of provides a filter on the things coming into G. It ensures that anything that comes into G will be positive. Do you agree? I mean, you're like, well, wait, what happens if you plug in a negative? Well, before we ever take the 3 halves power, that thing's going to become positive, isn't it? So I think this is all reals. But there is one other snag here. And that's this, I don't know, we could graph it maybe to see this if you're not seeing it yet. But see, there's something wrong here. One way to see it too would be to plug in -2. Let's do that together. What happens when you plug in -2 here? And actually, I don't even care what you get. But I do care that it's what? It's something negative. If you plug in -2 here, you get something.
Wait a minute, what?
So actually, I have no problem with this. The domain is all reals. But actually, I have a little bit of a problem here. That maybe those two expressions aren't actually equal. What's going on? Math broke. No, math didn't break. This is actually what's happening here. There's also an 8. There's also a cubed in there. But do you agree that in the process of doing this, we've got a square root of a squared, of x squared? What is that? Is that x? plug in some numbers. What is that animal?
No, because always cost is first in the premise.
The absolute value of
Oh, I
x.
swear I'll
Absolute value.
So if you want to simplify this, there we go. I think all now is right in the world. Okay.
Wait, why is that?
Huh? What about functions not using absolute value?
Wait, no, wait.
All right. That's a decent place to be. I think you'll be fine on homework 4 tonight. I will see you tomorrow.